to a discussion on dividing rational expressions. Okay, so we're going to think about fractions again. In this case, we might have what we want to think about referred to. How about the fraction 4 over 9 divided by the fraction 12 divided by 3? Okay, so if you remember, the steps were to rewrite the original, or the first fraction that appears, replace the division symbol with a multiplication, which can be denoted as an x or a dot, which would probably be better in this case so we don't confuse it with a variable. So we rewrote 4 over 9, and we're going to multiply. What we had to do is flip, or take the reciprocal of the second piece. So we write, instead of 12 over 3, we write 3 over 12. And what that does is allow us to cross multiply, like we did in the previous section. So 3 will go into itself one time, well 3 will go into 9 3 times. Over here we have 4 will go into itself one time, well 4 will go into 12 3 times. So what that does is leave you with, on top, 1 times 1, and on bottom we have 3 times 3. So that's going to reduce to the fraction 1 over 9 when you multiply across. So looking at some examples in the procedure, to divide rational expressions, first multiply the reciprocal, completely factor the numerators and denominators, simplify by dividing out common factors, and then multiply the factors left in the numerators and multiply the factors left in the denominators. So to actually apply these steps, we might have something like example 1, simplify the rational expressions. So we have 6x plus 6 over 5 divided by 9x plus 9 over 10. So the first thing to do, rewrite the original fraction of 6x plus 6 over 5, then replace the division symbol with a multiplication, then flip the second fraction. So instead of 9x plus 9, you have 10 over 9x plus 9. Okay, now what I would suggest doing would be to factor. The first thing you really want to notice is that 5 and 10 are very common. So 5 will go into itself one time, but 5 can go into 10 two times. Okay, noticing that over here, 6x plus 6, both of those can go into 6. The 6 and the 6 right here. So looking as if 6x divided by the 6 we're pulling out, we're just left with 1x, or just x. Okay, and this plus 6 divided by 6, we can just say plus 1. So that's factoring that side. And down here, noticing that 9 can go into both 9x and 9, I can pull a 9 out, leaving you with 9 divided by 9x. It's just x, or just 1x, plus 9 divided by that 9 right there leaves you with 9 divided by 9 is just a positive 1. Okay, so if we say that there's an x plus 1 right there, and x plus 1 right there, they cancel each other out, just leaving 1. So on top we're left with 6 times 2 over 1 times, and don't forget the 9 right there. So we're left with 18 on top, excuse me, 12 on top divided by 9. And believe it or not, this can be simplified even further, because you can think of 12 as the multiplication of 4 times 3. Well, you can think of 9 as the multiplication of 3 times 3. So that would just leave you with canceling these 3's out, leaving you with 4 over 3 as a solution. Looking at this next example, we have 3y over 3 minus x divided by 12xy over x squared minus 9. So first, we write the first fraction of 3y over 3 minus x. then put your multiplication symbol. Let's flip the second fraction to have x squared minus 9 over 12xy. Now let's begin to factor out. You can see that x squared minus 9 can be broken into x plus 3, x minus 3. So that will replace this term right there. Okay. Now let's notice that we have 3 minus x. You can rewrite that as negative x plus 3. Now which is just pulling out a negative 1, and that would just change the sign. So x minus 3. So that would cancel out these previous two terms. So now let's just do some factoring out. 3y will go into itself one time, while it can go into the 3 can go into the 12 4 times, and it will cancel out that y, just leaving you with 4, and don't forget your x. Okay, on this other term, diagonally we have x minus 3 here, and we have x minus 3 here. So now just taking what we're left with 1 on top times x plus 3 that's left over negative 1, don't forget that negative 1 right there, times 4x. So to just simplify, we have x plus 3 as a quantity over negative 4x. Okay, looking at number 4. Let's first rewrite the first fraction that appears of x squared minus 4 over 24x. Now let's do our different rules of multiplying by the reciprocal and having 6xy over 2 minus x. Using our ability to factor out, we can note that 24x and 6x can cancel out because 6x can go into itself one time, while 6x can go into 24x 4 times. Okay? So looking over here, we have negative x plus 2, and again we can factor out a negative 1, changing the signs of x minus 2. Okay, and over here we can see that we can break this into x plus 2, x minus 2. Now identifying what's in both sets, we can see the negative 2, the x minus 2 appears both times. So we're left with, cancels out there, so x plus 2 times 1 over 4 times negative 1. We're just simplifying, we have x plus 2 over negative 4. And note that the y up here was a part of this 1. So we actually have on top that quantity multiplied by y. And these cannot be simplified further. That's as far as we can go. And looking at number 5 here, our last example for this problem, we have the quantity x plus 2 squared over x minus 2 divided by x squared minus 4 all over 2x minus 4. So, first step, let's rewrite the first fraction. Let's replace that division symbol with multiplication and then just take the reciprocal of the second fraction. So we have, for the second part, 2x minus 4 over x squared minus 4. Now let's just go through and factor. This first term right here actually looks like x plus 2 times x plus 2. Okay, now we can't do anything here on the bottom. Over here we see that 2 can actually go into 2x and negative 4. So we pull it out, we have 2x divided by 2, we're just left with 1x, or just x. And finally negative 4 divided by 2, we're just left with negative 2. And over here, x squared minus 4 turns into the fraction x plus 2, x minus 2. Okay, now let's go through and identify. We can actually see that x plus 2 appears here, and diagonally across from it, it appears here. So those two are canceled out. Noticing we have x plus 2 here, and it cannot be simplified below or across diagonally, so we move on to x minus 2 on the bottom, which appears here. If you look diagonally across, it appears there as well. So everything that is highlighted is canceled out, leaving us just with x plus 2 times 2 all over x minus 2. If you want to take it further, you can distribute this 2 across everything in parentheses, but for our sake, you can see that that problem is simplified.